that I discussed in the past with regard to the graph, everything is required for you to answer this question. The equation of the graph is not given. Okay? And you cannot find or you cannot calculate the x-intercept, the stationary point, and all that. You can't. You have to use the notations that are given. So let's start with the first part. The first part says if g is a cubic function with g3, okay, g3 equal to g prime of 3 equal to 0, what does that mean? It means there is a specific point where x is 3, y is 0, which means we have an x what? Intercept. So when x is 3, y is 0. Then what does g prime of 3 mean? Equal to 0. G prime of 3 equal to 0. What does that mean? Because here there are two things that you need to be aware of. The G3 equal to 0. This is an x-intercept. Okay? What does G prime of 3 equal to 0 mean? What is that point? Alright, listen, before we go anywhere, if you see the prime, what does it mean? It means derivative. So, where is the derivative equal to 0? It's a turning point or a stationary point. Okay? Please, don't get confused. The moment you see this, it means you are talking about the derivative, the gradient. Okay? Just to remind you, the derivative is also the gradient. The word derivative, I told you in the past, it's a calculus word for gradient. Can you stop it? If you want to go out, you can go out. The word derivative is the same for gradient. So g prime of 3 means the gradient when x is 3 is equal to 0, which will be a turning point. What did I say if an x-intercept is at the same point as a turning point? What did I say? Alright, what does it mean if an x-intercept and a turning point are at the same point? What does it mean from your understanding? Huh? Yes. Yes, the x-intercept is the same as the x value at the turning point, which means one of the two turning points is on the x-axis. One of the two turning points is on the x-axis, which means the general equation of this graph, if I were to write it, it would be y equal to a times x minus x1 squared times x minus x2. Alright, so the general equation of this graph is going to be that one there, which means we are going to have a turning point on the x-axis. I'm going to repeat that. If an x-intercept, or if a value of x at the x-intercept is the same as the value of x at a turning point, it means that the turning point will be on the x-axis. Alright? Then G0 equal to 27. What does that mean? Right? So G0 equal to 27. This is a y-intercept. That's a y-intercept. All right? Can you try to move? Can you stay back and go? Where is it going back? You're not here. You're not there. Today you are here like you are being forced. And where is that? Next to here. Quickly, please, bro. Don't waste more time. Where is it at the back? All right. So G0 equal to 27, that's the y-intercept. All right? Which means we know that the graph is going to pass through a point where x is 0 and y is what? 27. All right? Then point number 3 says G double prime of x is greater than 0. What does that mean? This G double prime of x is greater than 0. Well, what does that mean? It's concave what? Up. Right? It's concave up. Now, if it's concave up, do we have a minimum turning point or a maximum turning point? Huh? To the minimum turning point. It's concave up means the graph is happy. Right? So, this means the graph is concave up. Then, now it's concave up when x is less than what? 3. Right? It's concave up when x is less than 3. Which means when x is less than 3. If I were to ask you, what will be the value of x at the point of inflection then? If you see this, what's the value of x at the point of inflection if you see that? It's going to be a 3. Okay? Pay attention. It means the value of x at the point of inflection is a 3. Right? Then G double prime of x is less than 0. This will be concave what? Down. Concave down. Okay? And again, it's concave down when x is greater than 3. Right? Now, I'm going to ask you this question. If x is less than 3 and the graph is concave up, what does this mean in terms of the turning points? Right? Is the minimum turning point to the left of 3 or to the right of 3? All right. Remember we said when it's concave up, it means it is happy. Right? The graph is happy when x is less than 3. Which means to the left of 3, the graph has a minimum what? Turning point. To the right, it has a what? So the shape will look like this. And you have a 3 somewhere there. Yes. Are you following that? Are you following? Yeah. Let's draw a sketch. Please, we are going to draw a sketch. It's not drawn to scale and it's not drawn to a specific accuracy. It's a sketch. You understand? Yes. Right. So let's draw it. All right. Okay. Now that I know the shape, okay. Now that I know the shape, my shape is like this. That's how it looks like. All right. Can I have your attention? Can I have your attention? So we said at x equal to 3, we have a turning point. So if I say this is 1, that's 2, that's 3, right? Like that. right? It means at x equal to 3 here, we are going to have a turning point there. Do you agree with me? Yes. Right, so we are going to have a what? A turning point here. Okay? Then we need to locate where x is 0, y is 27. Now in this case, because it's a sketch, I can say maybe this is 5, that's 10. This will be 15, then 20, 25, maybe I'll put 30 there. So let me calibrate where my 27 is going to be. 27 is going to be somewhere there. I'm going to plot where 27 is. All right? Then we need an x. Remember, when x is 3, we have got 2 x-intercepts. Do we know the second x-intercept yet? Do we know the second one? We don't. We only know one, which is x equal to what? To 3. The second one we don't know. What that means is, when I sketch this graph here, to the negative side of x, I don't have to put a specific value of x because I don't know it. But I know that the shape looks like this. So it means when I sketch it, it will look like this. It will be like that. Right. Right. Let me put my point of inflection first. Right. My point of inflection, it's at x equal to 3. But the 3 now, the 3, remember this is where 3 is, x is 3, y is 0. What that means is, there is a possibility that this graph might only have one x-intercept, right? Which is going to be this point here. It will only have one x-intercept. So when I sketch it, I can sketch it as, remember here we have got a y-intercept. Do you remember that? We have a what? Y-intercept. So when I sketch it, since I'm going to have a minimum turning point here, right, I can sketch it as, okay, wait. All right, I said, okay, we have got x equal to 3, y equal to 0. This is fine. Right, at x equal to 3, there we have got turning. Then on the other side, it's going to look like that. If I started from the top, then I go over to. Hey, listen, it's not wrong for me to think. Yeah. What means going down? Alright, if you say it's going to go down, then what about the minimum and the two turning points? Okay, wait, let me think now. Okay, if I go down, then I go down. Alright, the graph is with one x-intercept, so I have to do it like that. And go down like that. Right. So that, listen, so that it is concave up, then concave what? Down. Right? Now, this shape here, it's a unique shape because the graph only has one x-intercept, which means there's got the same x-intercept 3 times. It means x1 is equal to x2 is equal to what? x3. So it's the third case that I spoke about yesterday. Okay, in this case here, it's a very unique case. It's not the most common one. Okay, this is not a very common case. All right? Okay, so then, but where's got any question there? So what this means is that we have, listen, it means we have a stationary point, which is also a point of inflection. So this point here, it's also a point of inflection. I'm going to repeat that. It means the x-intercept is a point of inflection. Okay, it's also our stationary point. There are three things there. That point there, this one, this point, it's an x-intercept. It's a point of inflection. It's also a stationary point. Okay? That's unique now to this graph. All right. Then, but where's got any question there?